Hello Algebra, welcome back. In this video I'm going to show you how to divide complex numbers. It's a little bit more complicated than anything else with complex numbers so far, but it's not so bad. So we're going to do this as an example, and I'm going to show you how we're going to compute this division problem. And I'll write the steps as I go, and then we'll do another example. Then I'll throw you to the wolves and you'll have to work on it your own a little bit. So your first step that I would like you to do is write the problem as a fraction. So if I'm taking 2.51 and I'm dividing it, or 2.51, 2 plus 5i divided by 4 minus I, that looks like this as a fraction. Then the second thing I want you to do is find the complex conjugate of the denominator. So here, our denominator is 4 minus I, and the complex conjugate only changes the sign. So our complex conjugate is 4 plus I. And in our third step, I want you to multiply the numerator and denominator by the complex conjugate of the denominator. So that's going to give us 2 plus 5i divided by 4 minus I, and then we're going to multiply that by 4 plus I divided by 4 plus I. And we're allowed to do this because these two things cancel out to be 1. This is something divided by itself. Okay? So I'm going to go ahead and multiply this out. I'm going to FOIL in both cases and then simplify. So 2 times 4 gives me 8. 2 times I gives me plus 2i. 5i times 4 gives me plus 20i. And 5i times I gives me plus 5i squared. In the denominator, 4 times 4 gives me 16. 4 times positive I gives me plus 4i. Negative I times 4 gives me negative 4i. And negative I times positive I gives me negative I squared. And all I have to do now is simplify this. So here I have 8 by itself, and I have 2i and 30i, and then I have this 5i squared to worry about. So 8, I'm just going to bring along for now. There's nothing I can add 8 to, so it's just going to come along. 2i and 20i together give me plus 22i. And 5i squared becomes 5 times negative 1. I'm going to have a similar game in the denominator. Here, I have 16. I don't have anything to add or subtract that to for the moment. And I have a positive 4i and a negative 4i. So together those become 0. And I have a negative I squared. So then this gives me 16 plus 0 minus a negative 1. That minus sign comes from here. This minus sign comes from the fact that I squared is negative 1. Okay. Now you'll see that 8 and 5 times negative 1, I'll be able to combine those. So I'm going to get 8 plus 22i plus 5 times negative 1 is going to be minus 5 over 16 plus 1. And that's going to give me 3 plus 22i divided by 17. And we're almost done. So this is not in standard form. Remember, our standard form of a complex number is it should look something like this, a plus bi. Right? That's what we want our number to look like. This does not fit that format. So what we're going to do is use our rules of fractions to separate this into 3 over 17 plus 22 over 17 times I. And that's our final answer. Let me do one more example for you. So let's say that we're going to divide 3 plus 2i by 1 minus 7i. So first I write it as a fraction, 3 plus 2i divided by 1 minus 7i. Then I take the complex conjugate of my denominator, 1 plus 7i, 1 plus 7i, and I multiply those two. So that gives me 3 plus 21i plus 2i plus 14i squared divided by 1 plus 7i minus 7i minus 49i squared. And first I'm going to do my I squareds this time. I'm going to deal with those first. And then I'll get 3 plus 21i plus 2i minus 14 over 1. I'm going to go ahead and change this to 0. I have 7i, and then I take away 7i. Plus 49. Now I have these like terms. So I have 3 plus 23i minus 14 over 50. Now I have 3 and negative 14 that are like terms. I get negative 11 plus 23i over 50. And then I take that as negative